What if the entire universe moved 1 centimeter? The Earth stays put as if nailed in place, and the entire rest of the cosmos shifts relative to it by 1 centimeter. The answer is still a little boring, but honest. Essentially, nothing changes. First, why only the cosmos moves is physically the same as only the Earth moves. In physics, there is no sacred 0 point that everything is measured from. There are only relative distances and relative motion. If you say, the Earth is motionless, the cosmos shifted 1 centimeter to the right, a physicist will say, that is just a different reference frame. You can say just as well, the cosmos is fixed and the Earth shifted 1 centimeter to the left. No experiment can tell you which of these stories is the correct one. So from the point of view of physics, it is the same situation, just described with different words. Second, let us imagine this is a real shift. Let us force ourselves to imagine that. The sun, the moon, all the planets and the galaxies moved by 1 centimeter relative to the center of the Earth. Then, the distance to the sun is about 150 million kilometers. The change is about 100 millionth of a kilometer. That is a change in scale of about 1 part in roughly 10 trillion. The gravitational pull will change by such a tiny fraction that even the best instruments will not see it. The same is true for other stars and galaxies. Their contribution to gravity on Earth is already almost zero. So formally, yes, all the distances of the form Earth to something have changed by 1 centimeter. But there is no real physical effect, no change in climate, orbits, time, or anything else. Third, what would we actually notice? For us to really feel anything, the changes have to be in kilometers, or better, in thousands of kilometers, not in centimeters. For example, if the Earth were closer to the Sun by millions of kilometers, its orbit, energy, and climate would change. If the atmosphere became thinner by tens of kilometers, that would hit temperature, radiation, and so on. On that background, 1 centimeter is not even noise, it is noise of the noise. If it is not 1 centimeter, but thousands of kilometers, then things really do start to change. Let us talk about changes on the order of from 1,000 to 200,000 kilometers. First, the scale at which we feel a difference. The distance from Earth to the Sun is about 150 million kilometers. The distance from Earth to the Moon is about 384,000 kilometers. The radius of the Earth is about 6,400 kilometers. So, adding 5,000 kilometers to the distance to the Sun is a change of only a few thousandths of a percent. Adding 5,000 kilometers to the distance to the Moon is already around 1 to 2%. The Sun does not care at all, but the Moon and the tides start to matter. Second, if the cosmos moves by a few thousand kilometers, from 1 to 5,000. Roughly speaking, everything outside the Earth, the Sun, the Moon, the planets, jumps a little farther or closer. The Sun, for us, the orbit of the Earth changes by a micro amount. The amount of solar energy changes by tiny fractions of a percent. No climatologist will feel that without ultra-precise instruments. The Moon, here it becomes more interesting. If the Moon is farther or closer by about 5,000 kilometers, its gravitational pull changes by a few percent. Tides will become slightly stronger or slightly weaker. Not an apocalypse, but in some ports the height of the tides could change by tens of centimeters. All tide and navigation tables would become inaccurate. Astronomers would also see that the Moon's orbit has become more elongated and would have to recalculate the ephemeris tables. Third, if the shift is tens of thousands of kilometers, for example 50,000 kilometers. Now the system really starts to shake. The Moon, a change of plus 50,000 kilometers is a distance change of roughly 13%. The gravitational pull of the Moon then changes by roughly a quarter. Consequences, tides can become much higher if the Moon is closer, problems for coastal cities, bays, and river deltas. Or much weaker if the Moon is farther, the circulation of the oceans will change. Extra tidal stresses in the Earth's crust mean a bit more small earthquakes in sensitive zones. Not the end of the world, but the statistics change. The orbit of the Moon could become very elongated. In the sky, it would sometimes be noticeably larger and brighter, and sometimes smaller. Satellites and global positioning systems. The orbits of artificial satellites do not fall apart immediately, but all calculations that take the gravity of the Sun and the Moon into account become inaccurate. Errors appear in navigation, astronomy, and geodesy. Everything has to be recalibrated. Fourth, if the shift is hundreds of thousands of kilometers on the scale of the Moon's orbit. Here we get into cosmic drama. Imagine that the cosmos relative to the Earth shifted by 200,000 kilometers. The Moon, for the Moon, this is about half of its current distance. Its gravitational influence changes by factors of several. Its orbit can become very unstable, or even evolve so that the Moon eventually escapes Earth's gravity, or on the contrary, falls inward. Not necessarily immediately, but the dynamics of the system are badly broken. If the moon disappears or moves very far away, then in the long term, the length of the day can start to change faster or slower, because right now the moon is gradually slowing Earth's rotation. The axis of rotation of the Earth will start to wander more strongly. That means strange seasons, shifting climate zones, and more chaotic weather on century scales. The night sky will be radically different. No familiar moon, no moonlight, no usual lunar eclipses. In short, not an instant explosion of the planet, but a long, slow chaos in the entire climate system. Fifth, what about distant stars and galaxies? They are so far away that even if you move them by 50,000 to 200,000 kilometers, for us that is almost zero angle in the sky. Constellations will look the same. Only this changes, the precise catalogs of star positions in astrometry. Very sensitive instruments will say, hey, something does not match here. The human eye will not notice anything. Summary: 1 centimeter changes absolutely nothing. A few thousand kilometers, things start to move a little. The moon gives slightly different tides and a slightly different orbit. Tens of thousands of kilometers, strong changes in tides, more stress in the crust, serious headaches for navigation and astronomy. Hundreds of thousands of kilometers. You really break the Earth-Moon system, unstable orbits, possibly a lost moon, and step by step, a very strange climate on Earth.